No! We'll leave it. Yes, I think we'll leave that. Hello and welcome to episode 32 of Writing a Little Interpreter in C++. And we're still thinking about pointers. The time is, well, it's a Monday, and the time is 10 AM. It's another day off. I'm home alone. It's probably the final one of the days off I'm going to do for quite a while. So I figured that we would probably have internet connections. Apparently I'm oh god, no internet. But hey, if that happens I can just code. Okay, so it looks like we're still streaming, even though the internet is saying I'm not. I say internet, but details. Where are we, episode? Now, hopefully that will pick it back up and say that we're still streaming. It says we're live, and it says we're doing some stuff. I don't know if I'm going through very well. Looks like I'm okay. So what's happening? We were on, God, was it Thursday? It probably was, that's why it feels like so long ago. On Thursday we've reached a point where we're having to start to think about error values. So these are values that can be written to. We're still thinking about error values, I'm afraid. The basic idea is that the left-hand side of an assignment is the L value, the thing to be written to, and the right-hand side is the R value. Oh, but R values in C++ have various subtypes, of which I cannot remember. They are important in certain situations, and then I look them up if I'm honest. I'm not a great fan of remembering this overly detailed things. I'd rather the language. Well, actually, they exist for a reason, so there's no need to rant about those. So, in our little language, we're only going to distinguish L values and R values. And why are they important? Why have we got to distinguish them? The reason is that an L value is written to, an R value is read from. So an R value has to return its value, whereas in the byte code, the L value, when we finish evaluating an L value, we need an address to write to. Or do we? Yes, we do, because we've got an assignment. The R value gets evaluated, and whatever it is, 10, 1,000, 10 plus 10, so maybe 20. The result of that is pushed onto the stack. The left-hand side of an assignment, we need to go, well, we need to evaluate you, and what should come back from you is where we want to write to. So we could say, well, the only place we ever write to. Write to for semi-permanent storage. Obviously we can write to the end of the stack, but that tends to disappear. Semi-permanent meaning local variable, so they disappear whenever we exit the function. The is being said a lot now. The address we need is going to be on the stack because we don't support dynamic loading, dynamic memory allocation. And from there, so we evaluate the left-hand side. It's either going to come back as a variable, so a variable lookup, at which point we need to implicitly take the address of, or it's going to come back as a pointer, which is naturally the right type. Let's see. Now this isn't important in the type checking. This is one thing to consider, that the type checking really is saying, it is not thinking about the implementation, so it's saying, can I put the right hand side, the R value, into the left hand side? And we can only do that if they're both ints, if they're both something. If the And even if we've got a pointer on the left-hand side, it has to be dereferenced to get to the correct type. You can't put an int, in our language, put an int into a pointer. So there's an implicit address of in the left-hand side of an assignment, or the left-hand side of a let. So anywhere an assignment can happen. Ooh, we know what we're doing now. Sunday last night was, I spent about an hour. I didn't really want to get too deeply involved in it, refactoring a few bits. Well, no, actually not refactoring, debugging a few things. So we have got a few, let's go to here. This is the example we're trying to get working. So we've got the main function. We do x equals 10. We create a pointer to x, and then we, via the pointer, change the value of x, and then we want to return, in actual fact we should be returning, that can stay, the value of those, but we also want to just return x. And here we would expect the value 4. Right, let's put that into here. What we're interested in is, we've got the test taken out. We're interested in what the, yes, we're already saying that. So we're interested in this guy. Right, so increase the stack to create space for the R value. I got distracted. In the process of getting this to work, I realised that my assignment was way down in the path in the atom section, when in actual fact I had the moment assignments in a statement, so it needed to be moved up, shifted up to the statement section. So we did that. We also changed the fact that I guess, also changed the fact that the left-hand side of a assignment was no longer guaranteed just to be an identifier. It could be a star identifier, so taking the value of a pointer to something, which meant that that the assignment now has a binary node, so it has a left-hand side and a right-hand side, whereas previously we implicitly stored left-hand side inside the binary node. That had a few knock-ons and a bit of fun debugging as I filter through things and change things, but got it mostly working. Anyway, back to us looking at this. Well, let's check what we've got here. We've got a variable identifier x equals 10, y equals the address of x, and then we assign, and there it is, the deref of the lookup of x. We assign 4 into it. And then apparently we're going to return the integer 4, which tells me I just did a typo. Stupid ball. Return x. Let me just quickly update a few things over here. In my classic buffer, we're just storing in my text editor, we're just storing off the bytecode instructions, so I can look at them when I'm debugging. I haven't really developed a good strategy for this. Possibly I actually need to genuinely write a little debugger that can display local variables and step and have breakpoints, and but I don't really want to do that at this moment in time. It would be fun to do. Okay, let's see. Yeah. Going into... Could this be already yawning? It's only 10 o'clock and I'm drinking my coffee already. E-coffee, not my coffee. My coffee would be the right way to say it? I don't know. So much slang mixed in with my language. Slang implies I'm from a... No. Incorrect uses of English would probably be better, which is probably the definition of slang, which I'm not now going to look up. Okay, that appears to be returning 4. How does that appear to be returning 4? Did I get this working last night and just not remember? That's returning 0, so interesting. So we think it might be this guy that's at fault now. Load stack address, offset 1. Interesting. I wasn't super concentrating last night, but let's zoom out so our see it all. Yes, and eventually these won't be here, but they are so handy that you, comma 4. Oh, that's why we took the whole line with us. And comma. These guys back in. No, not you. Goodness me. Let's have a little look. I'm hoping for some data output somewhere. Oop. Stop and rerun. That doesn't look hopeful. Something's got stuck in an infinite loop. Okay, let's find the pause button. Okay. The obviously. Oh, not that guy again. This is the best test ever. 136. Constantly fails. Just constantly fails. I should just leave it ready to be put back in, shouldn't I? Oops. And stop. So I'm just looking at the AST at the moment. We should print out the. What did I just change? I haven't actually changed any code yet, have I, this morning? Oh, I guess I didn't run them last night. For variable definition while, check, less than that. Code block, blah, assign to next, assign to C, +1, yep. Right, let's have a look at the assembly. I'm going to start calling it assembly because I keep thinking it's assembly. The bytecode. Holy moly, we've got 30 lines of it. What's my favourite saying? Holy moly. I assumed when I started streaming, one of the, I would say or a lot, which I do. But the other thing you become aware of is some of the weird things you say, like holy moly, which is off a kids' TV program I used to watch with the kids. It's stuck with me. And I use it a lot at home to almost make fun of people and less out, so you become more aware of your variations of your speech in different places. That's a real tangent. I'm trying to speak while I read custom bytecode, so this ain't gonna go well. Those offsets are massive. Unless they're absolute values, which I don't think they are. Load 2, load 4, load 8, load 12, load 1, no, I suppose they're okay. 4, 4, 4, 4, 4, no, they're okay. We had jump 10, pop, read local. 1, see, 1 is really an address, not an offset. Dun, 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 dun. So it should be FP plus 1, shouldn't it? Right, let's have a proper read. I can't spot, nothing springs out. I wonder why there's 2 read zeros there, that's a bit weird. Right, let's read it properly. Jump to offset 3, ink stack by 2, so we have 2 local variables. Get the address of local variable 0. Load I32 onto the stack, and then write the local. Well, we got that. I'm sorry, going off screen for a second. Let's just check write local isn't doing something weird. Compile to code. We've got the 2. Yep. Something going on there, and the implementation. We get the back off of it, whatever it is. That's going to be the right hand side. And then we do FP. You know what? It's debug time, which means piece of paper time, draw a stack time. As always, it's bytecode, and even though we have an upward stack in this machine, we pretend it's downward, and I don't know why. We need a break stack here. Break point. The other thing you realise is how much of, well, my speech anyway, is slightly incorrect or errors. You know, I'm thinking it, I'm not vocalising it, which means many people must autocorrect what I say. And then I wonder, do I autocorrect other people's stuff? And I realise that very often I do. Okay, now I'm guessing that we're not actually at the right place. No, we probably are. Let's have a look in the program, see if it's what we think it's going to be. Code should be about 30. Yeah, that's good enough checksum for me. So, we've not debugged a stack for a while, so let's enjoy this. Okay, F8 is step. One exit to get instruction. Ink pointer. Made a space for the return value of the program. Yeah, let's carry on. Next is going to be variable function. So we put fp, and then we're going to put the instruction pointer. And our new fp points just past that. And then we put our destination. Now we're at this, we should do that twice, because we've got, now let's look, we've got x first and we've got y, and they both are currently 0 because we initialize everything to 0 in our language at the moment. Now, address of local push element. What have we got in here? I think it's a 0. Yes. Now we've got ADDR X. Well, let's just get some values. Zero, no, it should be 0, yeah. So what's in 4? 0 and 0, because those are x and y, 3 and 4. Now, we go to here, we should have 5, which is going to contain 3, which is the absolute address. Correction. It is the offset from the beginning of the stack to the local variable x, which is currently 0, which is why we initialize them both to 0. Okay, so we've loaded that in. We load some data in. Why are we loading data in? What's our instruction pointer? Let's check this properly now. IP is 5. Loading the value 2. Oh, we're still doing initialization, aren't we? Remember, the LHSs are converted over to being addresses. So we're going to load in the 10. So we're still at the x part, aren't we? Initializing x. Yeah. Right, local. Now x should be 10. No, x is not 10. We have something wrong. But of course, I've just stepped past it and there's no way to step back. We're in a state machine. Boom. Boom. Right, at this point, we are, I believe, initializing x still. On the back of the stack, we should have a 10 and the address of x to be written to. So let's have a look. 2. That's rubbish. I'm not expecting a 2, I'm expecting a 10. but we do have the correct offset. Why am I expecting a 2? Or unless I misread the code. Yeah, oh, it is a 2. And so I want to see, to update my assembly bytecode and source code. Yes, so we're loading a 2, which is fine. Now we should be popping that 2 off the back. He says with enthusiasm. Yep. Now at position 3 we should have written 2x. No, we haven't. We've written it to 4. We've written it to 2. Oh god. No, because that's already 2. What have we done? Oh, let's have a look in GDP because I can print that out, can't I? Doesn't need the frame pointer because we're using the address, it's going too far. Now I wonder, so that my question is, that I think is going out past where we're at. It might not be. Let's see what Valgrind says about it. Valgrind doesn't say anything if we don't exit. There we go. He's doing anything? Okay. Maybe, maybe not. That was a read. Read local. Now, I'm wondering whether that is also an issue. No, that's still read as an offset from the FP. Good. Right local is when we get pointers up, we're doing a big refactor, reducing of to-dos and all this. Right, let's go back to where we were. The first right local should now be working, he says. enthusiasm. 2 is written. Yes. First bug found. Address of local. Now this is going to be Y. So we're expecting a 4, are we? Yep. It's good to make predictive guesses. Let's see if you're meant to modify it. Load it. We should. Oh, let's see. Anyway, but that should be 0. Yep. Here we go again. What's on the back? I don't know why I did that. 0 because we're initialising it to. And 4, which is our offset. Okay. Okay, that makes me reasonably confident that 0, but we need no initialise to 0 because what comes next? We're going to read a local, so we're now into the reading X. And we are reading the data 256. Then we're going to do a compare. Okay, let's just check that 256 2. So we should do a less than. I'm not quite sure what instruction is next. Text, test. It's an integer test. I should rename that to iTest. No, it's not, is it? Don't be stupid, Paul. It's just looking at the result of the test which was pushed onto the stack. Pushed onto compare flag. Wasn't it? Compare flag should be set when the previous test was successful. It's not. Good. Anything with that equals the pack. Oh no, right. Wake up. The greater than, less than from the while was pushed on a 0 and 1 onto the stack. Now the compare flag's getting hold of it. I would say it would be more efficient. No, because we assign to it, don't we? So. Just set that, so we. God, is it even going to work? What's redo? Let's check that out. Okay. Whether this is going to work. Okay, so jump 0. Good, we didn't jump out. off the stack now. Test, good. And what are we reading a local now? So we're now entering the x equals x times 2. And we should read a local. Load data. We should multiply next. Multiply. So I'm now expecting at the end of the stack a 2 and a 4. I'm not expecting a 2 at this point. I would be expecting a 3. 2 points to the instruction point of the return. So let's see where we go next. Write local. RHS. You can see something's gone wrong with this increasing, which shouldn't surprise me because that's what's stopping us from exiting. Why am I going into here to look at that? Oh, well. 2. Right, so we've got the test. You can pop read local 0, read local 0. This first one should be the address of, a bit like we had, wrong screen, sorry guys. Here we're reading local, and we're reading local, which about 15 minutes ago I said, oh, that looks odd. This first one is for the assignment. This second one is, so this one should be an L value. This one should be an R value. And then we multiply them all, and then we write the local. But unfortunately, for me, we don't get the address, we get the value of, which is 2, which is crazy. It will overwrite our IP pointer. Before we fix that, let's just check the hypothesis by keeping an eye on number 2 here. So when we return out of main, this is the instruction pointer, so the next instruction to execute once we return from main, that will be a halt. So it's a return from there and halt. But in theory this, if our hypothesis is correct, should go to 4. Yes, it does. So we have a gen problem. We're doing a read local, and we should be doing an address of local. That is strange, to say the least. So those were lets, so the other one was an assign. This is our first assign, shall we say, not print. Put a bit more space on it. Go to the top just so I show you. Okay, so how is this different to let? Which is always the interesting thing. If it's even there. Okay, we don't have a let, do we? What does it do? var def, of course. Oh. Let's check this in your coaching. Yep. Tell me that. He does down here. I should get used to seeing the information. Which leads us back to identifying, but we're back to where we were thinking that the var def and assign are, for all intents and purposes, the same bit of code here. But for some reason, one of them is generating an address of, and the other one is generating a reading the actual value, which is what we don't want. So what have we got going on that's different? They are not pointers. We've got a var def going into there, we've got assignment going into here, we've got a state, you've got an identifier, whereas here we have to have an expression. Then we've got an assignment. There you've got the type. Assign, logical or. We don't alter the AST anywhere. Well, what can we say? But let's have a look at them. See what's going on. See what crazy system you've created, Paul. Got a first child. So this is the one we're just seeing in the first child, not the second child. So where do you go? You go to an identifier, which gives us the address of. Okay, good with that. Def and assign. Now you are something else, aren't you? First child. If you're a variable lookup, that's where you're wrong. You should not be a variable lookup. Therein lies the problem, that we need to know when to do a var lookup and when to do a address of. So when to do a deref, when to do an addr. So at the moment we only, I'm guessing in the parser, if we go to atom, we will see what I don't want to do is I don't want to do another scan through. So we see an identifier and it gives it a var lookup and kicks out. Right, let's go back to here just to talk this through. I've got an idea. I'm not sure it's a good idea. we have is LHS equals RHS. Now, LHS is an L value, so must result in an address on the stack. So I'm just going to check stream health is okay. No comments and there's nothing going on. That's cool. Address is on the stack. The RHS must result in a value that's on the stack, but we're not really interested in that. So what can this is annoying because I can't zoom in. New file. There you go, now I can make this bigger. When he zooms in. Okay. B. It can be ident equals RHS. It can be star ident equals RHS. What it cannot be is x plus y. Okay, this, okay, that's incorrect. It can be that, but only if I'm an upside down arrow. Here we go, something like that. This one is a specific form of calculating an address. Calculating an address, which is the most simple form. In theory, we could do something like star of x plus 20, for instance, which might index into a slice or an array. Actually, my ARR 10, or slice more likely 10. All those are resulting in an address coming back. So, what we want to do is thinking, ooh, I have a specific bit of code. This is a special case, basically. Because all the others are returning addresses, so it's a special case in our logic, but it's also the most common case. So, thinking in the path, I just go, hey, you've got to look up back. Lookups are terminal nodes. So just modify to be an identifier. Yeah. And then we have to rename some stuff because once it's working, once it's working. This is done because I wanted to, it serves no use other than it's a renaming of a variable, which makes more sense in this if area. Some people say it's a redundant thing, but I kind of... So if we just do that modification there, really not happy about something, is it? Which I cannot spot. No. Have it. That's what type language is awesome. The result of x is 7. Yeah, I think that is going well. That is going well, like I know that's going well. I'm just going to main. Good. What we've got now happening is the previous bit was a mistake for my refactorings. Now we've got something going on in one of the new tests. I've got the right to from the pointer is no longer working, which makes a hell of a lot more sense as that's why I'd expect things to break. Now let's get this one back out. Where were you there? Control V. I probably got it there anyway, haven't I? Expecting 4, we got 10 back. So it's that one that we got. Okay, didn't actually harvest off those. And while we're here, we'll have to turn the turret back on to produce the right code. Excuse me, mister. Now, unfortunately I can't put my reasoning in that scratch file because I like to look at what I'm debugging, unless I can break it out. I can. So, this is much better than using get it or something. Goes on saving. Right, let's read the AST. We've got a function called main. What a surprise. There are no parameters. We've got a definition x, which we assigned to 10. We've got a definition of y, which is the address of, we assigned to the address of x. We now assign do a deref on I. That deref needs to be void. And then do a lookup on Y. The deref needs to be void because that's going to write a value out. So if we go back down to somewhere in here, write local address of x, address of 1, yeah, load stack offset 1, load I4, write local. It appears to be working. How the blah is that working? Well, the code appears to be right. What does it? Does appear to be right, doesn't it? That's fascinating. What shall we do? What shall we do here? What are we doing with the deref? Questions to be answered in the next episode of Coding a Compiler. Am I on screen? Yeah, I'm darkening out, aren't I? How's that? We have sunlight. It's weird. We have blue skies. I should be outside running or whatever else I should be doing. That's better. Instead, on bytecode interpreter. Okay, I'd actually rather be doing this because I could be doing the other things. Two interesting things that I'm wondering. Why the hell have I got a deref in there? It needs to be there for the a little looky. Oh, and then I'm going to make a coffee. Interpreter, that's you. deref. Load stack address. Interesting. Why is it doing that? I got a feeling I'm going to make a mistake here because I got a feeling I'm fixing up the write to case and breaking the read from case. Load stack address. What does load stack address do? Pushes what we've found onto the stack. That's not what we want in this instance. We want to make the left hand side be an L value. So special case logic, special case logic. That doesn't have a deref. This one, only sign has a deref. Let's go with special case logic because you know. Deref is special case logic is good. I'm actually starting to think that I should just put braces always on case statements. No, because you've got other stuff. Whoops. Now what do we want to do? What do we want here? We want to ignore the deref. How do we ignore that? We ignore it by skipping it. Or hitting the wrong keys. F9. We get 10 back. Do we want to get 10 back? No, we don't. Why don't we want to get 10 back? Because we're doing an assignment. Let's see what I did wrong. Helps if you write code properly, Paul. Get the 4 back. Awesome. You can go away now. Scary times. Woohoo, they all passed. Do I have any pointer tests up here at the moment? Good. I was worried I was breaking some of these, but I wasn't. Right, so you work, but you obviously do. Mr. Interpreter. They all pass just about. Let's make you slightly bigger so I can see your results. Main, come back main. You are already in there. This guy, I'm hoping, returns 4, but you need to I'm going to go 7 in this case just because. 111, yeah. No, do you want to do that? Do go. Result is 3. Result of x is 3. Does that look right to you? No, it does not. Why is the result 3? I would expect 20. Very quickly. To recap, we have done 2 ad hoc. I feel like ad hoc they are. One ad hoc and one okay. So leaning the wrong way, sorry. Solution to things. So the first one is, when we're in an assignment, if we get a fail, we'll look back in the parser. We just say it's an identifier. The second one is that ensures it falls through and gets read as an address, which makes more sense if we're in the middle of an expression. Then they're all okay. They're all read as lookups because they're the R value type. in fact, that is a very good idea. We can start calling them R values and R, identify R value. Where are you? Value. That will make it much clearer through the code what we're doing. I probably might do that soon actually. And the next one is that when we're in an assignment and we're generating a bytecode, if it's a deref, which is converting from a pointer type to a value, then we just say no, we don't need to do the deref here because we're going to be using an address. I think most compilers do something like this, so I'm happy with that for now until I figure out something that's broken. This is very broken. I want to know why. Which was a toggle true false. Here it is. Load stack address of 1. Confusing musing. Load stack address of 1. That should be load something else. But if we look here, that's right, that's fine. So I think we've got another bytecode problem. So I'm interested in plus, aren't I, this time? Come on, little machine, skim past all that. Skim past this stuff. I think we're heading for a interpreter util at this rate. Plus, plus, plus. Unary plus. No, not unary plus. Where are you? Here you go. Here we go. Not wow, wow. Let's actually have a debugger breakpoint. Variable definition, variable definition. What was the actual string I'm looking at? Oh, sorry, I missed that. So, effect over you, going to you. Deref. Yes, it's wrong. We're loading and addressing when we should be that's practically the address of. Oh, no, that's right, isn't it? Why is it? Is it a bytecode thing? Load stack address. Why is that there? It doesn't need to be there. That's just confusing the world. Not that that's going to make any difference. 3. I wonder why. Touch my face a lot. Weird observations. Not weird. Normal observations. Nothing weird about here. Right, so we've got a problem. We've got a deref which is reading the address, putting it onto a stack item, and that's saying, yeah, you're fine. Then we're adding a 10 and an address, which is odd, and we're getting 3 come back. Really what we want is loadex. Load. Why is that not calling? Why is that not doing a... Why is it not doing that? 20. Probably broken something else. Here we go. Ooh. That would teach me to refactor when tired. This is going to be a fun one. Semicolon oh yeah, didn't take away the brace. That's better. Result 100. Right, gonna make a coffee, and while I'm doing that, I shall think about a plan. What do I want to get done? I want to fix that, obviously, and I probably want to write some error tests. Then we go from there. Right, I'm going to leave it running because I'm only going to be 5 minutes while I make a coffee. Oh, yep. Just thought, well, maybe I should check the sound. Well, we don't have to open up Emacs now. No more Emacs. Oh, sad. Scratch pad. Here we go. How can you do? Okay, I shall turn that off, and I shall see you in 5 minutes. we're back. Always good here. I can't believe I've got to episode. Oh, stuff on the floor. Put away, stupid stuff. It's my phone. Okay, it's very clear that I've got the darkest room in the house. I really should make the most of the sunshine, so I shall endeavour to eat lunch outside today. We're there. Let's check the feed status. If I can find my way back. No, I've lost it. There it is, live dash. What do we say? What's going on? Nothing is going on. Yeah, I do love the, right, no you don't, Paul, just get on with things, Paul. Okay. Where were we? Let's have a quick look at the screen. No. The poor webcam is facing a window, so maybe I can make it darken out and adjust it, so no, maybe not. Excuse me. What I'd like to do today is figure this out. Write some failing unit tests for pointers. Now if we get that far today, I'm happy. Result is 100. You should not be 100. Let's put all this. Okay, let's just have a quick look at it. If we get this working, I'm going to be happy. Because this afternoon I want to maybe have a little run on first little stream of deving the tiniest game I can think of using SDL2. I've long wanted to get back into a bit of game dev. And I very much always end up starting to write an engine, and that's time consuming. You never actually make a game. I do sometimes use other libraries, which particularly Raylib, which is pretty awesome. But invariably I end up with a nagging feeling I'd rather be writing that sort of code myself. You know, everyone should be using Unity, I know. But as it's for fun, hobby stuff, I don't have a problem with that. So I felt Raylib's a little bit too high, because I do like to get into the really fine details. SDL2 is a bit of a aging interface, but it's pretty good. It's compatible everywhere. It's doing all that. So I thought, right, I'll start with SDL2, and then I got lost in OpenGL. So I'm like, right, back off from that. I was only doing 2D OpenGL, so I didn't really get that lost in it. But I thought, nope, back off from that, and just, what's the minimum you need? You need to be able to draw stuff. So you can use the STL2 rendering for sprites, text, subject, texture regions, whatever you want to call them. And so I was like, if I put it all the way back, so we just use STL2 and maybe a few other bits, but just that, and then move forward and make a game. And the plan is, make the smallest game you can think of. Put it on my website. Job done. Move to the next game. Think of a game that's slightly more complicated. Just make that. You know. My main focus is NHB anyway, so I don't get a load of time. So there's no point pretending I can write some MMO or even a single an RPG or anything like that. Just slowly, just boom, build sort of my tech base up and enjoy doing it. But not the priority. Having said that, it is fun code, and it tends to be, well, once you get to a certain level of game dev, it's not just the code you're thinking about. You have to think about psychological elements, you know, the gamer, are they enjoying it, that sort of thing, and which presents a different challenge. And obviously there's always a challenge of graphics, but I'm at the point where I'm probably just going to spend money on graphics and try and improve at the same time. so much graphic-y stuff out there. I would just find a sprite set for Space Invaders, buy it for £10 and whatever it costs. I don't even know. I don't know if you can buy stuff like that. But I shouldn't be doing this on the NHB stream. Sorry. Just saying that this afternoon I'm probably going to stream something else, a bit of game dev. Okay, why are you failing? You've got the setup. You're not failing. Well, you are failing, but you are pathing. Right. Return. So we're looking here. Can you guys? Yes, I'm sure you can see that. We're turning. We're multiplying two values together, which is correct. We're looking up the value of x, and we're dereffing the looked up value of y. Y is the pointer, so that's fine. That all looks correct. I should track the line numbers, shouldn't I? Right, so return value. Right, local. Here we go. Read local 1, 0. Read local 1. That doesn't seem good. Load a stack address 0. No, that seems right, because you get loading a pointer. Load a stack address. That's interesting, because I'm not sure that 0 is meant to be there. It's not. I'm quite enjoying seeing, as we're adding features, some things are being clarified, some things are being simplified as it reaches there. I mean, I will admit I knew what L values and R values were, but I hadn't thought about the implication when you actually come to implement them, that there's an implicit UNL value, so you really need to be the address you're being written to. UNR values, you really need to be the value at the address that the local variable's at. I'm not really quite fully appreciated that, what was going on there. And, which I now do. All is good with the world. Right. Now we're getting a bit more sensible. So load address is right. We need to go for read local, I reckon. Kill off all those. Not there. Not there. Okay, so wonder why. Okay, I'm not convinced there wasn't a bug there. It seemed to be doing something odd, but I don't know if it's me missing keys or you can't see any that because it's not on the screen. Sorry. There we go. Let's debug it. Get focused on that. The first one, read local, is this here. So the have a look at the stack. Stack. We're not choosing you. In fact, we're not choosing any of those just yet. 5 should be 10, yes. Now we're expecting the next read local, which will be the next thing, will be something else. 3. Okay, that's good. Load stack address. So ADDR is the value 3. We should we should get a 10 back. So let's go to here. Print stack 32 and whoop, you get the value 10 back. Or 1.4 times 1.4 e to the minus 44. No, didn't want to do that. I want to go back into here. Now at the top of the stack, you should have 2 value 10s. Yes. Ah, it's a multiply. Oh god, I'm being a dumbass. Okay. I'm sure everyone who ever watches this video, if anyone ever does, will just, you know, that's embarrassing. Multiply. This means multiply. If you have 10 and 10 and you multiply them, you get 100, not 20. Ah, that's cool. See, this is what happens when one has too much coffee or not enough. Yeah. This is why I write unit tests. Right, what do we want to do? When do we want it now? Taking that out. Good. I have no idea what I just did then. Which is never a good sign. You're pressing buttons and weird stuff is happening. Where are we bouncing around? Way too much. Duplicate. No, I didn't want any of that. It was a waste of time as well. Vim, I know, would have done that in 3 key presses. Okay, let's do the office. Let x equal 10, return address of x. Expected a type keyword. Oh. Expected type check error got. General error. Parser didn't like that. that's because we're missing a semicolon. So we have a check no error, don't we? But I don't think... So if no errors... I reckon, I don't know. I think I should be using that more here. And probably here as well. Don't want to remove them because they're useful, but yeah. Awesome. Right. Duplicate. They're not really that interested in multiple errors at the moment. Glad that worked because I just saw another good test down here. You do the address, the value address of X. You don't need Y. Then you go 10. Cool. You don't have a test failing. We were getting some error tests put in. Unexpected characters, ampersand. I can live with that. That seems a pretty cool thing to happen. So we've got that parser problem. Awesome. Right. We create a return. If it's not equal to a curly, I would say we've got a problem there straight away. There should be a semicolon. Let's pretend it did it. A logical OR. Go into your logical ORs. Oh, true bar. Yeah, do that. Ah! Logical AND. Logical comparison. Plus or minus. These need to be handled from left to right, so I'm effectively recursing, aren't I? Is that the right way to do it, I wonder? Probably. fact that I'm fixing these bugs so quickly implies that there's loads of bugs I'm not finding, because some bugs take a day to fix. And if you're fixing the ones that only take 2 minutes, it means that you are not finding the hard ones. That was a rubbish error message, but that's also a rubbish error message. To expected one. Yeah, the fact I'm just deleting them. I should probably just check the first error message, shouldn't I? Yes, you are. Yeah. Random number of error messages supported. That should give us 2 maybe, or maybe even more. Yeah. Only 1 error message this time. Yeah. Is it worth doing other types? It is, although I'm not really. Cool. Right, I'm going to say pointers done. No, we're nowhere near done on pointers. Basic pointers done. So we can point to something and we can take address of something. We can't do pointers to pointers, we can't do any pointer arithmetic, and we are not handling dynamic allocations at all. The pointers are offsets from the FPs, and no, the pointers are actually stored as offset from the start of the stack. Given that we moved the stack to not allocate to get pointer stability, I would say it makes sense to to just have them as a pointer. It does lead to the ability to, if in the debug case, we could instrument the lookups to make sure they're inside the stack, if we expect it to be inside the stack, which we will know because if we're reading a local variable, then we can do the check. If we're not reading a local variable, then we can't do the check. That may be useful, may not be useful. I'd say that's a static analysis problem, isn't it? So what I'm wondering is whether or not you could detect stack writes to the stack that when it's, writes to memory not inside the stack, because you could in theory return pointers and all that sort of thing. We should write a test where you send a pointer into a function and return that value. Which may lead to many more problems. We cannot yet do pointers to constant values, so we will struggle. More work. Good. These are what tests are for. Through 10 we will not be able to do. I don't think. Semicolon expected. Oh yeah. Not sure I'll make more mistakes with or without semicolons. Type mismatch in return. Of course. Good. Actually telling me something. Yeah, so we can't convert that to a pointer. What would you do? That's good. I think x. No, I'm sad. I32, I32, return the value of foo, which is an I32, type mismatch for argument 0. Void expressions not allowed in returns. Foo is not void, foo is this. But that's gone all bad, so we got an error, so we're returning a void. Hence the reason second error message in type checker is bad. We may not even generate it. We might just go into panic mode and not recover. We'll see. And what were we thinking about? Function definition, main. You're not being printed out right for starters. Parameter, not being printed out right. We need to improve the printing of types. Okay, why did I run it again when we're doing that? I have finished my coffee, it's heading towards lunchtime, so type mismatch for argument 0. Shift F9. No. Control F8. Right. We're really interested in this, aren't we? Can implicitly convert. So there's your false. Your pointer check should not be there. If they're the same types, you're good to go. We don't have any implicit conversions. Now it works. Yet another simple to run test. Okay. Here we go, even better now. Let's return it back out. Crazy as it may seem. That's gonna fail. No. This is a good example of where things can go bad. If I return a pointer to a local, it will run. and it will probably work in this instance, get the right result. But if I then stored that pointer, did some more calls, I'd overwrite the stack where the value 100 is called, because it's no longer within a used stack frame, and it could be, could have 10 written to it instead, or some random number. This is the sort of thing so if we had something like this, then returning an address to something of memory that we technically own, but it is in an invalid state, or I go up invalid, not necessarily undefined. And that's the sort of thing you want to stack it checker. Say you're returning a pointer to a local variable. It's fine to take the address of a local variable as long as it doesn't escape the function. That in. Did that work? Oh no. Let's do 105. Because that's a number. Cool. Testing. Done. Well, I'm not super hungry, but I'm going to pause for some lunch, I think, because that'll give me a long run this afternoon. So I'm expecting to stream probably twice more today, once this afternoon for a couple of hours, and probably once in the evening. One of them is going to be a game dev stream. I'm actually inclined to spend the afternoon now tidying up NHB. I think we've got pointers to an OK state. Therefore, we need to, but we've lowered the clarity of the code. We've introduced the concept of L and now R values in a to-do. We need to tidy that up. We've got a lot of, I believe it was in the type analysis, this sort of thing going on. And, okay, now that's fine. Come on, you. Where are we? Concrete type. This sort of stuff. Where it should be I appreciate that. I don't actually have a problem reading that. It's totally logical to me, but this is slightly cleaner. It comes at a slight cost because you've got another function call going on. We can do, if we find debug is getting really bad, then I will fix it. I will rewrite it in a macro. Sounds a terrible thing to do, and I seriously doubt I'll ever do it, but if it becomes a big issue, that's fine. I can sort that out. It's a shame C++ doesn't have, I suppose, rant. Macros are really easy to write, slightly hard to get wrong, slightly easy to get wrong. Right. But they do have some nice attributes for debug. They're always in line. It'd be nice if I could just, if you had a keyword in line, that said just always in line, force in line in all cases. In the debug build, literally a textual description, textual replacement, along with some mangling of the variables, which could then the debugger could sort out so it's highlighted properly, which would help. Would mean your code was fast in debug and fast in release. I spend my life in debug. I want it to be fast. And we don't have a mechanism for doing that in C++ very easily. I don't think a forcing line even works in debug. So you don't. So you end up writing code like this, or you write a macro to hide that code. Macros, you get them wrong. I'd rather write it in the language. I could rather write, auto LHS guy. I'd rather get a type. Get LHS node. I'd rather be able to write that and it be what have we got? st node star get LHS st node star parent set parent first child. Much rather write it in language like that. Obviously at module level or local variable level, I guess, if you do landers. But then I'd like to be able to do here force inline. Script, what do they use? They use @, don't they, or something like that. Hash. No. What do actually use? Dad, isn't it? Not force or inline. Always inline. I don't mind. If I could make a function work like that, maybe I can. Maybe I need to look at these new attributes. And that happens in debug. It happens in release, so I get consistent behaviour. I'd be happy. I actually quite like the square brackets. I originally didn't like these square brackets. I've not really used them in anger. I tried to use false through once, but failed miserably. Didn't quite do what I wanted. Yeah, if I could do that and not have to debug, that would be my ideal. Because otherwise, you start doing too many of these, you get these slowing down in debug. They're always function calls. You're doing a lot of them because it's access for nodes. It's hard to build, hard to develop code because you want your compiles to be faster than the time it takes for you to get distracted. Anyway, I want wrapped. It's a human element, not a in code. There's a lot of human elements. You have to think about what's going on. Yes, it's great to have everything type checked, but it's not great. You've got to wait 4 days for it to happen. And that is part of the reason I am writing an HP, to explore my thoughts on programming. That's good. Yeah, so this will be dull, boring work. Please don't come back. Damn. Yeah. Yes, I think that's it. Maybe overload begin and end. Oh no. No. Excuse me. Let's use a sentinel value. That might be fun. We could get rid of these and do for each loops on them. C++ style, which would again reduce the noise and clutter. We've got some renaming work to do. We've still got this to handle, which we're not going to do. I mean, this is the worst. get any RHS. You know, we should be able to write get RHS node. Then suddenly we're not worried about how it structures there. If I decide to refactor, I've got less places to do it in. Blah 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 blah. That will be the focus. So before I sign off, let's just check. What did I do? How do I discard that? Show diff. What do I want to delete? Let's revert Control Alt Z. Cool. Let's do a couple of things we like to do. Talking about small games, I'll do that in a second. Also, it's bonkers how slow C-Lock is. You know, it says it's doing 4,000 lines a second. Okay, we're up to 3,500 lines. Not bad. I have no idea. And final thing, let's do a rebuild and see how long that takes, because I'm talking about these things and ooh, look at that, 1 second. Seems to be staying constant, and that's maybe because I'm not producing many lines. We're not making heavy use of anything by the code we write. We're not deliberately avoiding the STL as much as I thought I might. And of course, let's do a valgrind run through. Because if that breaks, we are fixing that after lunch. Valgrind is running. Valgrind is not happy. Nothing to show. Even that, I mean, that even compared to a week or two ago, Valgrind was running through in no time. You want Valgrind to be able to run through in a reasonable time. At the very least, I mean, it just ran all through all the tests. I'm not happy with how long it took. Valgrind finds a lot of good things, but you want Valgrind to run through in the amount of time it takes you to make a coffee. That sort of thing. You don't want Valgrind to take all night, ideally. Not the end of the world if it does. I mean, it's not in your, mostly it's not in your general flow of things. And I think Valgrind has the same issues as debug, except it's magnified. Cool. I'd probably, yeah, I should do a release build as well. Can't remember how to do that in CMake. What a debug. Why are you not letting me do release? It'd be nice just to do release here. But no, you've got to spec vendor macro in some release after that. I can't remember. See how often I build in release. Yeah, so I'm going to have some lunch. And while I eat lunch, I'm going to decide whether to do the game programming stream tonight or this afternoon, and from there I'm also going to decide whether to do, obviously, the NHB tidy up stream. I think I might go with that. I'm edging towards doing that this afternoon. We only have an hour or two anyway, so that will be a nice little thing. Gain some clarity. I don't feel like the code is quite there yet in terms of we shouldn't move forward with this code yet. We need to tidy it up. I need to get clarity in my head. I don't feel pointers are that well embedded in yet. But after that, we need to do our little plan. Support for pointers for types. Should I go with done on that? Well, we think we can do more. Lay byte ritual and string literal. As we can't move, we need to, okay, that's a definite. We need to think about arrays of data. Or we think about structures. I don't know. So arrays leads to slices. And thinking about how that's going to work. Structures are probably slightly less design work. We just have a structure. You send it in. What it will mean is, what will it mean? It will mean that we can't index local variables via parameters via their simple index, because you're going to need to index will have to be offset by a 5. Shouldn't matter too much. I'm not too worried about that. Might be structures might be useful to get going. The big keyword is, the big question is, do I use struct or do I use type? And how unified are enums going to be with the structures? If you use type, you could do type blah or foo or bar, and if they have nothing on them, they're considered enums. But enums have other attributes that the structure doesn't, so maybe I should do enums as a different thing. You've got a type and enum. Type is one less letter to type. Struct is very well known. But I'm not worried about very well known. Am I? Yes, I am. Am I? No, yes. Class. Yeah. That was an insight into my brain. The next big one will either be structures or types. This is the cluster of things we want to get through, because at that point we need to write up the spec. Good point. At that point we are to the point where we've probably got a usable language, with the exception of how do we interface with stuff. And as I'm trying to do the minimal cuts on everything, like entering internal as a vector, which will have absolutely terrible performance as we write more than 20 lines of code. But we shall see that, and we will fix it. And if we don't get to seeing it, which means we probably not writing lots of code, then we have other problems to fix first. Yeah, so we want structures, and we want that. Then we want to be able to interface with other code, and that will lead to a few questions like memory allocation, and that sort of thing. So I would say we arrays or structures. And then we have special support for strings, or at least char pointers of some type, byte pointers, I don't know. Although I'm thinking that is probably covered by having a U8 type. And we can maybe alias a byte type. And add a way to convert pointers to arrays and vice versa. Yeah, that's more about integrating with C. So, after a long time, we're here. I'm now officially stopping for some lunch. And I shall see you over there when we shall see you after lunch, where we shall decide, I will have decided what we're doing next. It is now 12:15. Looks like the stream was 2 hours long, and I have talked and talked and talked. I wonder if there's a... What if your tongue can get tired? You talk for long enough, or get an ache in your tongue, or your speech just goes down and down and down in terms of understandability. I can feel my throat being not good. Okay, right. meandering around in a stream of consciousness that is probably not that interesting. So I'm going to stop now, and I shall see you in a little while, or not. Next stream will be duller than this one. Okay, that's a great way to say it, isn't it? Hey guys, come watch me code some dull stuff while I refactor code and get distracted by stuff. Come back. Right, lunchtime.